Hello, Nova Online Math 161. In this video, we're looking at section 3.2, topic number 3, exponential functions applications. Suppose that $50,000 is invested at a rate of 6.5% interest compounded monthly. Determine the total amount in account after 10 years. So I'm going to highlight the keyword right here. The keyword is compounded monthly. So here's the formula for compounding interest. You can find the compounding interest or the accumulated amount by doing A equals P times 1 plus APR divided by N raised to the N times T power. Now, when they said compounded monthly, we're going to use the N value of 12 because there are 12 months in a year. So if you're doing quarterly, you're going to be using N equals 4 because there are 4 quarters in a year. So you need to look for that keyword that comes right after compounded. Compounded monthly, you're going to use N equals 12. So let's find that total amount A. Well, let's start with P first. P stands for the beginning amount, like how much is invested in the beginning. We call that principal, and that will be $50,000. So let's plug in 50,000 in for P. Open the parenthesis, and we're going to just keep on going with that formula. 1 plus, and APR, they did say that the rate is 6.5%. We must convert 6.5% into decimal. And we can do that by dividing it by 100. 6.5 divided by 100 is 0.065. And that's what we must use for the R, or the APR value, 0.065. And we're going to divide that annual rate by 12 to convert it into a monthly rate. Now look, the exponent has to be how many months we have in 10-year period. How can you figure that out? Each year has 12 months, but if you're looking at 10-year period, you can get the number a month by doing 12 times 10. And that's the setup. That's the only thing we have to do. Now we're going to use a scientific calculator to evaluate for the answer, okay? So I'm going to open up a calculator. I'll go to Desmo's scientific calculator on my computer screen, and I'm typing in 50,000 times 1 plus 0.065 divided by 12 raised to the 12 times, I'm going to have to do a parenthesis around that power, 12 times 10. So when I type that in, I got the answer right here. So we're going to say after 10 years, this investment will grow to be $95,609 and now let's round that up to 19 cents because this number is bigger than 5, 19 cents. So that is how you can find the accumulated amount using the compound interest formula. Let's try another one. Let's try another example on part B. Suppose that Luna is investing $7,500 now in a retirement account that has a rate of 4.25% compounded continuously. Now, we can't be dividing by infinity or raising base to infinity times however many years power. So for these cases, guys, anytime you get a problem that's using the key phrase compounded continuously, here comes the formula. A equals P times e to the RT power. So here's the hint. When you see compounding or compounded continuously problem, write that formula down. This formula will be used to solve for exponential growth or decay application problems that is compounding continuously. A equals PERT. So they're asking Luna will not touch that money until her retirement in 35 years. So time will be 35. How much money will be in the account at that time? So we're trying to find that accumulated amount A. What's P? Well, P stands for principal, the initial amount in this investment. So we're going to put 7,500 for P. E is just a number. Now, I'm going to show you what E is, okay? Now, if I ask you guys, what's pi? Well, everybody knows that that's approximately 3.14, blah, 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 right? That's that irrational number that we use to find circumference of a circle or area of circle in middle and high school, right? Now, the other very popular irrational number is called E, okay? Take a look. If I ask my calculator, hey, what's A? It's going to say, well, we don't know what you're talking about. What if I do B? They don't know what I'm talking about. C, they don't know. But here's the thing. If I type in the letter E, guess what? They know exactly what number we're talking about. E is called an Euler's number, and E is approximately 2.71828185. So this number right there, but it's too long. It's never ending. There's no pattern to it. So we're going to use the symbol E to represent it. Okay, so this number is like the most popular irrational number that you're going to work with in pre-calc and calculus. But if you never saw it before, don't worry, your calculator will, or any scientific calculator will have a button for E. So when you set it up, just leave it as E. Okay, you do not have to plug in 2.7182. Just leave it as E, and the calculator will use that exact, or not exact, that very long approximate value. So let's go and plug in the rest of it. I need to find what R is, the rate. When they said 4.25%, we need to convert it into decimal by dividing it by 100, or you can just move the decimal place 2 to the left. So R is going to be 0.0425. So let's put 0.0425 for R, and T is how long, like how many years is Luna investing? Well, she said she's retiring in 35 years, so we're going to multiply that decimal by 35. So that's the setup, and we're going to now go to the scientific calculator to type that in. So, okay, let's say we have $7,500 today, and just invested for 35 years. How much money are we going to have in 35 years? Let's take a look. So I'm going to type in 7,500 times E to the 0.0425 times 35. So look, wow, that's a good news for Luna right there. She is going to end up with 33,195, and now let's round to the nearest cent. This is about money. 12 cents or 13 cents? Well, looking at that number of 4 right there, that's smaller than 5, we're going to have to round that down to 12 cents. So the final answer for this continuously compounding investment situation, our answer is going to be $33,195.12. Notice that we use two very different formulas for part A and part B. And it's all about, which formula and which key phrases tell us which formulas to use. So if you're working on a problem that says compounded monthly or daily, semi-annually, quarterly is a common one too. If they give you the specific compounding frequency or period, then go ahead and use this compounding interest formula. But if they give you, if I ask you for compounding or compounded continuously, you must use this A equals P times E to the RT power formula.